Now, good morning, good evening, that is wherever you are. Anupam Chanda from Boston. That is, today I am going to discuss about that is delamination of glass and problem and solution. Glass delamination, the separation of glass layer or the formulation of flakes due to chemical or physical stress presents significant challenges in pharmaceuticals and other industries. Key problems include the potential for particulate contamination in drug products, compromised containers integrity, and increase risks of product recalls. This is the big loss of the company. So you should be very careful. Solution involve optimizing glass composition, manufacturing process, and storage condition alongside rigorous testing and monitoring. These are the that is points, that is problems associated with drug, that is glass delamination. These are the problems: particulate contamination. Flakes or particulates from the delaminated glass can contaminate the drug products, rendering it unstable and suitable for the use. This is occurring, that is during the manufacturing of the glass or vials, that is the flame application is more than 2500 degree temperature along the neck and the bottom surface. The the is so high temperature, that is evaporation of magnesium and boron is, that is very high. Sodium and there is magnesium is very high. In place of that, when it is evaporate, that is silica accumulates these places. That is product recall risks. If delamination is detected after this distribution, it can necessitate, that is expensive and damages product recalls. This is a big loss of the company. Chemical, that is degradation. The process of delamination can involve chemical reactions between the glass and the product, potentially affects the product stability and efficiency. Increased cost. Delamination can lead to increased cost associated with testing, product loss, and potential recalls. So each and every point please note down. Delamination problems, that is I have seen in the US market, that is when the product reaches in the market, that is I have seen the problem in the when I pick up sample from the chemist shop or anywhere. That is the solution, and the solution to prevent the glass delamination: optimize glass selection, that is choose glass type, that is type of borosilicate. You can go for the with inherent resistance to the specific products, pH and chemical composition. The one by one, that is solution I am talking about. When you will feel that is your product is failing in borosilicate glass, you can try your product stability in aluminosilicate glass or polymeric, that is that is vials and cartridges, that is COC, COP, or any other, that is compositions, that is composite polymers. Enhance manufacturing process control, forming temperature, annealing, and other critical parameters during glass manufacturing to minimize stress and defects. Careful product formulation, minimize the use of highly basic solution, buffers, and other substances that can accelerate delamination. Appropriate sterilization methods, that is you have to select, you have to keep your product in different sterilization process. Primary packaging material for the steam sterilization, gamma sterilization, or this like that. So optimize sterilization process to minimize thermal stress on the glass container. So when you will keep your primary packaging material carry out in different, that is sterilization process, so you have to keep the samples in different like the vials, that you will see in which that is vials, that is your product is more stable. Control storage condition, maintain proper storage temperatures and humidity to prevent moisture related delamination. Rigorous testing and monitoring. Implement, that is comprehensive testing protocols including stability studies and particle analysis to detect delamination early. Surface treatment. You can consider surface treatment like ammonium sulfate treatment to enhance glass stability. You can go for the siliconized coating as well. So you have to check after coating, that is, you have to check the stability, carry out your product in the stability studies. Collaboration. Foster close collaboration between glass manufacturers and pharmaceutical companies to ensure vial compatibility and address potential issues proactively. So, these are the problems and solutions I already explained. That is, when you will procure the primary packaging material, first procure for few samples for the stability study, and if you are innovator, NDA project, so you don't have any benchmark sample. For that, what you have to do? That you have to first study thoroughly the product characteristics, keep your samples, ask for the different, that is that is glass vials in different ways. Borosilicate few are that is aluminum silicate glass vials. Second option is you have to procure few samples for the COC and COP vials. When you send these samples for the different sterilization process, gamma sterilization, that is steam sterilization, like that. So then you have to carry out, that is, stability study in different the such kind of samples, and closely monitor the stability samples, that is which your product is stable in what type of, that is in which conditions, that is. So that is when you will feel, that is your product is stable, for example aluminum silicate glass, or so for example, that time, that is you can start making the specification, primary packaging material specification, and this primary packaging material specification has to be signed by packaging development quality control QA. So they have to sign, send the specification to the vendor, this vendor, and then you can ask for the, that is purchase department, to procure for the commercial supply. So when you that is get the material also, that is incoming packaging material, QC department has to check thoroughly and take care of that. That is the product, that is the samples you received that time for the stability studies, and the sample received for the commercial production is matching. So thank you very much. Like and subscribe my channel, please.